Hello all, this is Mikalavashi Reddy from CSC AML section department and currently I'm pursuing my BTech at Institute of Aeronautical Engineering. Today we are going to discuss about purity of metals to control corrosion. So these are some of the topics we are going to discuss in this session: corrosion, causes of corrosion, effects of corrosion, theory of corrosion, oxidation of oxidation corrosion, electrochemical corrosion, purity of metals, and concluding this topic. So let's dive into the topic. So, corrosion is a natural process that converts a refined metal into a more chemically stable oxide. It is a gradual deterioration of metals by a chemical or electrochemical reaction with their environment. Corrosion engineering is a field dedicated to controlling and preventing corrosion. Metal corrodes when it reacts with another substance such as oxygen, hydrogen, and electrical current, or even dirt and bacteria. Corrosion can also happen when metals like steel are placed under too much stress, causing the material to crack. So here is a reaction explaining clearly what is the cause of corrosion. So ore of metal, which is actually stable in nature, which is converted into a pure metal, which is by some metallurgical processes, and rusting, which is basically converting into its original form, which is also stable in nature. So effects of corrosion. So, effects of corrosion: loss of useful properties of metals, that is, malleability, ductility, conductivity, decrease in the production rate, increase in maintenance cost, and contamination of product. So, here we can see a small image of corrosion of steel happening. So, here we can see firstly the metal getting somewhat corroded, and later this corrosion later on spreads on to the steel and making it an undesirable material. So theory of corrosion explains about two types of corrosion: dry corrosion or direct chemical corrosion, wet corrosion or electrochemical corrosion. Direct chemical attack. Direct chemical attack or pure chemical corrosion is an attack resulting from a direct exposure of a bare surface to caustic liquid or gaseous agents. There are two types of dry corrosion: oxidation corrosion, corrosion by liquids, corrosion by gases. Oxidation is defined as corrosion reaction in which corroded metal forms an oxide. Usually, the reaction is with a gas containing oxygen metal such as air. Metal systems need to form dense, well adherent oxide films. The oxidation of steel does not form well adherent oxide scales. So here we can see a small image of oxidation corrosion. So the reaction is iron metal, which is reduced into iron plus 2 plus 2e minus, which is 2 electrons reduced, ferrum atom at metal surface dissolve into moisture film, leaving negative charge in metal. Corrosion continues as depolarizer removes electrons from metal. Common depolarizer are oxygen molecule plus 4 moles of water gives rise to 4 electrons plus 4 hydroxide electrons reduced. As in acidically, two hydrogen positive ions reacts with two electrons to reduce into a hydrogen molecule. Cation of more noble material metal is copper plus 2 plus 2e minus gives rise to copper. Electrochemical corrosion occurs when two dissimilar metals are present in an electrolytic medium. Seawater is an efficient electrolyte. Different parts of same metal made dissimilar by treatment of a metal and its oxide are sufficiently dissimilar to create such corrosion. Mainly, there are two occurrences: evolution of hydrogen, absorption of oxygen. Evolution of hydrogen. This reaction occurs in acidic medium. At anode, iron reduces into iron plus 2 cation plus 2 electrons. At cathode, 2 electrons plus 2 hydrogen plus ions reduced forms H2 molecule. Overall, iron plus 2 hydrogen cations gives rise to 2 mole- ferrum plus 2 cations and H2 molecule. So here is a small image. We can see a steel tank containing salt water, which is when a metal is immersed in it. Following reactions takes place, but instead of iron, we can take any metal, and here we can take copper. So here steel acts as an anode, and the metal immersed in it basically basically the metal immersed in it acts as an anode, and steel can which is which is preserving the metal acts as a cathode. So evolution of hydrogen, rusting of iron in neutral aqueous solutions like NaCl in presence of atmospheric oxygen, resulting in surface of iron coated by thin layer of iron oxide. At anode, iron is reduced into iron plus 2 cations plus 2 electrons reduced, but at cathode, zero point 0.5 molecules of oxygen reacting with water molecules and 2 electrons gives rise to 2 hydroxide molecules. I mean 2 hydroxide ions. Overall, Fe plus 2 plus 2 hydrogen molecules gives rise to ion OH2. So here is a small figure which is depicting the evolution of hydrogen. So here we can see in aqueous neutral solution, so we can see these two particles, I mean two ledges which are separated, and medium the medium entering these wedges. So zero point 0.5 oxygen molecule plus 2 electrons plus H2O gives rise to 2OH minus. So cathode is large here, and flow of electrons takes place such that Fe gives rise to Fe plus 2 plus 2 electrons. So oxygen oxide thin film is formed on the surface of the metal. So here anode is small and cathode is large. So let us dive more into the topic. So causes of rusting. Concentration of corrosive effects on material when electrode potential of material is high. Gold, silver, platinum, noble metals have least corrosion rate, whereas other metals like magnesium, zinc, platinum, zinc, aluminum with low electrode potential undergo corrosion with low electrode potential and undergo corrosion faster. The high difference in electrode potential between two metals that are in contact with each other have a great chance of corrosion. For example, when iron is in contact with copper, iron corrodes rapidly. Taking this into consideration, the same metal should be used and usage of dissimilar metals does not be taken into consideration. So basically, one of the causes of mm, corrosion is purity of that metal. Content in molecular level of a metal is very important. In the case of corrosion, pure metal have less chance of corrosion, but in case of impure metals, due to presence of minute electrochemical cells, they are having a high chance of corrosion. So, corrosion control methods. The corrosion resistance of a pure metal is usually better than that of one containing impurities or small amounts of other elements. However, pure metals are usually expensive and are relatively weak. In general, this category is used in relatively few cases, which is are more or less special. Aluminium is a good example because it is not that expensive in a fairly pure stable 99.5% plus. The commercially pure metal is used for handling hydrogen peroxide, whereas where the presence of other elements may cause decomposition because of catalytic effect. In other case, localized attack of aluminum equipment occur because of segregation of impurity, iron in alloy, reduction of maximum iron content, agreeable of both producers and user eliminated the localized attack and satisfactorily performance of equipment was obtained without added cost of material. Another example is arc melted zirconium, which is more corrosion resistant than induction melted zirconium because of more impurities in later. This is a special case in an atomic energy application where a little corrosion is too much. So, conclusion. Even though making a metal pure makes it resistive towards rusting, but this causes a lot of cost, and some metal are very rare to find, such such that is too difficult. But on plus side, if iron metal used in pipelines be available in this method can be used in this material as it is easily available such that making it a suitable method. So here we can see a percentage of aluminium Al 99.99, rate of reaction with HCl 1%, and 99.997 thousand and 99 0.230,000. So rate of corrosion is inversely proportional to purity of metals. Purity of metal decreases, foreign metal content increases. Electrochemical corrosion accelerated so that metals easily undergo corrosion. So thank you all for attending this session. I hope you enjoyed this, and this is Vasit signing off.